That brings us to a discussion of procedural design versus an object-based design. You're all familiar, I'm sure, with procedural design, where you're writing your code as one monolithic entity, and in a procedural world, you have shared state in terms of global variables, and you may have private state in the caller and the callee, and state is now distributed all over the place. So basically, the interface between the caller and the callee is through this normal procedure call mechanism that one subsystem may make a procedure call that goes into another subsystem. And this is how monolithic kernels are built, where state is now strewn all over the place. There may be some shared state and private state of subsystems and so on. And this is typically how monolithic systems are built. To contrast this procedural design to object-based design, in an object-based design, objects contain the state that is entirely contained within this object, not visible outside. And there are methods that are inside this object that manipulate the state that is part of this object. So in other words, externally, the state is not visible. The only thing that is visible are the methods for invocation, and these invocations work on the state that is local to the object. So what you get with an object-based design is strong interfaces and complete isolation of the state of an object from everything else. Contrast that with the procedural design, where the state can be strewn all over the place and the shared state can be manipulated from several different subsystems that are part of a big monolith. But in this case, what we have is strong interfaces that completely separate one object from other objects, and the state that is specific to an object is contained entirely inside this object, invisible to other objects outside, except via well-defined invocation methods that are being exposed by this object implementer to the outside world. As OS designers, the immediate question that might come up is, well, if we have these strong interfaces, it sounds similar to what we discussed when we talked about the structure of operating systems early on, and that is border crossing across protection domains. Is it going to cost us? But there are ways around it to make these border crossing performance conscious as well. Now, where to apply this object orientation? Well, in Spring, for instance, they applied object orientation in building the operating system kernel. So the key point to take away is, if object orientation is good at the level of implementing a high-performance operating system kernel, it should be good at higher levels of the software as well. And while I am expounding the virtues of object-based design here, we've already seen this when we talked about Tornado system. That was also using an object-based approach to building operating system kernels.